In this video, I'm going to show you how to use Tinkercad to create a basic logic circuit. So this is software that you don't actually download. You just go to tinkercad.com and you create a free account. So this is web-based software. So I'm going to go ahead and log in. So you would just create, if you don't already have an account, you would just create an account. So I'm just going to log in because I already have an account. But it's very simple to create an account. So you just go to tinkercad.com and you should be able to see how to create an actual account so that you can use the software. Okay, so once you have got your account, then what you want to do is go to Designs. So if you go to Designs, this is where you want to start from. And for this one, I'll just go ahead and create a new design. And we want to do circuit. So we're going to do a new circuit. It gives them these kind of funky names. So I can just change this to basic logic circuit. You can give it whatever name you want. It'll save all your designs in your account. And by default, it lists basic components. I like to go ahead and just click all, so that I get all the components, and you can just scroll up and down to find whatever you need. And so what I want to do for this example is actually implement this circuit that I did in Logisim. So I have another video using Logisim. And so I'm going to implement this top circuit. The bottom one is just an AND gate. So if you can implement the top one, then the bottom one would be very simple. So I've already labeled the pin numbers for my different gates. So this should be very straightforward to translate this from a schematic to what you might know as a wiring diagram that you would have on your actual breadboard. So I'm going to be using this as my example. I'll move it out of the way so that you can see what I'm doing in Tinkercad. Okay, so first thing we need is a breadboard. And so if you scroll down here, they got different ones. I'm just going to grab this one here and left click. And then if you use your middle mouse wheel, you can zoom in and out like so. All right, so this is just a basic breadboard. It shows you when you, if you roll your cursor over these different parts, it shows you what's electrically connected. So the columns are electrically connected, separated by this. And then these rails are electrically connected. And so it's a typical breadboard layout. So I am going to need 2 OR gates, 2 AND gates, and an inverter. So, and then I'll need some an input switch as well. So I'll go ahead and I'll just go ahead and start building it. So I'm going to need some pull-up resistors. So I'm going to put 10K, a 10K resistor there. So you just left click and drag. If you want to rotate something, you just hit R. The R key will rotate. And these all need to be 10K. So I'm going to have 4 inputs. So I've got 4 inputs. Okay, and then I'm going to need a switch, and I need a 4-position switch. And I want to rotate. So up here there's a rotate, and there's also a mirror, which I can't mirror on this component, but I can rotate it. And the reason I want to do that is so that on is down, which means that when the switch is down, it's on, which would be a 0. So when you're going through the binary, when you're counting in binary, it just down is 0, up is 1. It just makes more sense. And then to connect wires, you just left click and drag. So I'm going to make here, and I'm going to change the color to black. So I'm going to use black for ground. So it's pretty easy. Just left click and left click. Okay. So now I've got my ones and zeros generator. Later on, I'm going to need a power supply, and that's going to need to be 5 volts. And so I'm going to left click and place it there, and I'm going to use red for power, and then you can kind of move these around to make it look nicer. And I'll need black for there. I'll straighten that, and we'll make that black. Okay, and let's pull that out a little bit. Okay. All right, so we've got that set up. Now we're going to need an OR. Well, I'll go ahead and do my LED circuit. So my output, I'm going to use a 330 ohm resistor, and I need an LED, and I'm going to put it down here and then rotate it around using the rotate, and see how the cathode is connected to the resistor. So this is where I would do the mirror. So now that I have the anode connected to the resistor, and then the cathode will go to the logic gate output. So that's how the mirror works, and then the rotate works as a rotate. Okay, so I have got my output side, I've got my input side, so now I just need my logic. So I'm going to need one of each of, let's see, I'll start with the OR. So this will be the OR gate. This will be the OR gate. And then I will have the AND gate next. And then I will have the inverter last. There. Okay. So all of these, pin 7 needs to go to ground. So pin 7 goes to ground, and then pin 14 goes to VCC. So that should be right. Okay. And so now it's just a matter of connecting everything with wires. And you can use different color of wire. And so let's get started. So so again, I'm going to be using this right here, which you're not going to be able to see, but I'm able to see. And then to wire everything up. So I've got A that's going to go to pin 1 of the OR gate. So A is going to be on the left. I want to go left to right, A, B, C. Oh, I only need, I've already made a mistake. I only need 3. I only need 3. So I'm going to delete that resistor. I only have 3 inputs of A, B, and C. All right, so A is going to go to pin 1 of the OR gate. So if I left click here, what I like to do is place it, if it shows you a box there, it's going to connect it to that column. And I actually don't want to connect to any of these columns. I want to run basically this wire down to pin 1 of the OR gate. So I could do it like that, but that doesn't look all that great to have wire. I mean, you want to keep wires kind of straight and at right angles. So what I like to do is basically come over here and make sure that a box is not highlighted, and then left click. And then you can make like a junction or a curve, and then do the same thing here. So come down here and see how the box is not highlighted, so I can left click, and then I'm going to pin 1 of the OR gate. So see, now there's a box, so I want to connect there. So that's how you want to do it. And so you can kind of straighten this up if you want. That's pretty good. Let's see. Yeah, I guess that's okay there. And I really probably want to use a different color, so I'm just going to use, say, green. Oops. So I'll highlight that and do green. Just so, I mean, I want to use red for power, black for ground, and then just use different colors. So I'll use, let's say, green for the inputs, and then some different colors elsewhere. Okay. All right, so we've got A going to pin 1 of the OR gate, and I want B going to pin 1 of the inverter. So B needs to go to pin 1 of the inverter, so, or the NOT gate. So I'm going to do the same thing and come down here and let's see, just run it. I guess along here, I've got to go all the way down to pin 1 of the OR gate, and so I can do that like that, and that looks pretty good there. Okay, so that's input B is going to pin 1 of the inverter, and it's also going to go to pin 4 of the OR gate. So it goes to pin 4 of the OR gate. So I can go, instead of running from here, like running a wire again, I can just basically go from here because I'm already connected. So I can go from pin 1 of the inverter to pin 4 of the OR gate. So that would be up here, like that. So I might make this one a oops. Let's make this a different color. Purple. Okay, because this is going to be an interconnecting wire. All right, so pin 1 of the inverter is going to 4 of the OR gate. Okay, and that also needs to go to 10 of the AND gate. So here's the AND gate, so I also need to go to 10 of the AND gate. And so I can do like this. Okay, and then come down this way. And then come up here and do like that. So now this also goes to pin 10 of the AND gate, and that should be everything for B. And then C only goes to 5 of the OR gate. And so C here is going to go to 5 of the OR gate. So let's come down here. And over here to there. And I'm going to make this green as well. Okay. So that takes care of that. So now I need to do the interconnecting wire. So I need 2 of the inverter to go to 2 of the OR gate. So pin 2 of the inverter will be down here, and I want to go all the way to 2 of the OR gate. So that is there. So that's just a straight wire. Like that. Okay. And let's see. And 3 of the OR gate goes to 1 of the AND gate. So 3 of the OR gate. So let's do that here. 3 of the OR gate is going to go to 1 of the AND gate. So that would be there, like so. And then 6 of the OR gate goes to 2 of the AND gate. So 6 of the OR gate goes to 2 of the AND gate there. So that looks good. And let's see. 2 of the inverter goes to 2 of the OR gates. So I've already got that. So and we just did 6 and 2. I'm looking at my schematic just to verify. 6 goes to 2. Okay. And now 3 of the AND goes to 9 of the AND. So the AND gate is here. So 3 of the AND, 3 of the AND is going to go to 9, so it's going to wrap around. So I'll do like that, and then 9 will be there. Okay, like that. So these, some of these are crossing over, but that's okay. You don't want to go over the chip. So we got 3 going to 9 of the AND gate, and then 8 of the AND gate goes to the LED. Right, so 8 of the AND gate right here is going to be our output to the LED there. Okay, and we'll just make that let's see, orange there. Okay, so I believe that's hooked up correctly. And so if I look, let's see, yeah, this is just a simple AND gate with A and B. So what should happen then, if we start the simulation, let's get all these down. Okay, so I've got A, B, and C going left to right, A, B, and C going left to right. And so right now they're all zeros. So A and B are 0, 0. So I get a 0 out. 0, 0, 1, A and B are still 0, 0. I get a 0 out. So the LED's on. 0, 1, 0. I've got 0 and 1, so it should be on. Same thing for 0, 1, 1. It's on. Okay. And then 1, 0, 0. It's on because A is a 1 and B is a 0. So it's a 0 output. 1, 0, 1 is the same thing. And then the last two combinations, it should be off. 1, 1, 0 is off, and 1, 1, 1 is off. Okay, so this is, in this situation, a 0 is turning on the LED and a 1 is turning off the LED. If you were to go back and do this in Logisim, it's the opposite. So here, a 0, LED's off, and a 1, the LED's on. The way we do it in Tinkercad, a 0 output is actually going to forward bias the LED and turn the light on. So it's just the opposite logic value turns on the LED depending on if you're using Logisim or Tinkercad. But anyway, that's it. And what's nice about this is this shows you how you would actually do it on an actual breadboard. And the reason it may have appeared I was going pretty slow is I was basically, just having to look at my schematic and get all my gates and my pin numbers right to be able to connect them over here in Tinkercad. So again, the 1s and 0s generators are on the left, the output LED circuits on the right, and then all the logics in between. And then you just need a power supply. I mean, you could also, you could also attach a multimeter, so you could measure the voltage at different points. And actually, that's a good segue. So basically, if your design's not working, then obviously you want to check all the wiring and that stuff. But you can find whichever combination's not working and start tracing using the multimeter. You can start probing the individual pins of the ICs and see if that makes sense. So if one of your one or more of your input combinations, say one of these input combinations is producing the wrong output, what you want to do is trace it like is done here in Logisim. This is showing you the logic value at each stage. And so basically what you could do in Tinkercad is attach a meter. So you would keep your negative on ground like here. And I like to keep these at nice angles, right? And so and then just attach, for instance, if we were to attach this to say just one of the pins that we're using, for instance, if we come over here, let's see, we're using well, let's look at our output. So if we look at our output, okay, then we should see a 1 there. So if we start simulation, then we have 5 volts, right? So we have 5 volts on the output. The output's going to the LED, so that's going to keep the LED off, right? And so by using the multimeter, you can probe the different pins to see if the logic is what you expect it to be. All right, I'm going to end this video for now, but this should help you get started doing some simple digital designs in Tinkercad.